Construction using a breadboard. Breadboards allow us to try stuff out quickly. You don't need to solder anything. You do need to know how to do a few things though. You need to be able to translate from an electronic schematic diagram into a physical layout. You also need to understand how breadboards work, and you have to know some basic stuff like how to cut and trim wires. To light an LED you need a power supply, shown here as VCC1 as a battery, a resistor R1 to limit the current flow, and the LED itself. The LED has two terminals, an anode and a cathode. The anode is shown as terminal 1 here, the cathode as terminal 2. The actual physical LED looks like this green LED here. The anode is shown on the circuit diagram, and the anode on the physical LED is the one, well, for a new LED it's the longer leg. And if you look inside the LED, it's the smaller electrode. The cathode is where current exits the LED, and on the physical LED you can see it's the shorter leg for new LEDs, or if it's been cut, it's the leg that connects to the thicker electrode inside the body, or you might notice that part of the case is actually a bit flat. That's to indicate which leg is the cathode as well. Resistors limit current flow. It doesn't matter which way around you put them, they still limit in the same way. This resistor here is 270 ohms, so the red band at the top here indicates 2, the purple band indicates 7, and the brown band indicates that there's 1 0, so we have 270 ohms. The battery is, in our case, a small battery enclosure. You might have got an AA battery enclosure instead of the AAA shown here, but it's the same, just slightly bigger. The positive on the schematic is the longer horizontal bar, and that is equivalent to the red wire coming out of the battery holder. Or looking at the batteries, it's equivalent to the little button on the top of the battery cells as opposed to the flat end. So the button end is the positive end. The negative leg on the schematic is the shorter horizontal bar, and that corresponds to the black wire coming out of the battery pack, or the flattened end. Now these batteries here are actually in series, so this battery here connects to the tail of this battery here, which connects to the tail of the next battery, which connects to the tail of the next battery. It gives us a total voltage which is 4 times one of the individual voltages. If you're using non-rechargeable batteries, that means you've got 6 volts here. Current flow around the circuit leaves the positive plate of the battery, heads round, goes through the resistor, down through the LED, lighting it up, and then back around to the negative plate of the battery. In our physical layout, we can lay out the circuit like this, where the red lead from the battery, the positive lead, connects to this horizontal bar here on the top of the breadboard. You can see that that's actually kind of slightly different color. That's the fritzing tool indicating that these terminals are actually all the same electrical point. So the red wire here is actually connected to this wire here, the blue wire, internally in the breadboard. That blue wire goes down here, gets connected to one end of the resistor. The other end of the resistor goes into the anode of the LED. The cathode of the LED connects down to this blue wire and back out onto the black wire back to the battery. So current enters from the red wire, travels along the plus bus up here, down the wire, internally again down to the end of the resistor, through the resistor, up through into the anode of the LED, through the LED and back down through its cathode, and back to the battery again. Stripping wires.
Stripping wires. Some people find this a bit difficult, and it does take a little bit of getting used to. So the idea is you take a snips like this, or a snip like this, just wire strippers, and you pull your wire over and pull, and out comes the metal interior of the wire, which can then be plugged into a breadboard, like so. Now, for long bits of wire, it's okay just to hold it with your hand. Let me just cut that off, and we'll start again, and then pull, and there you go. That's about enough. about a little bit less than a centimetre of wires, just plenty to allow you to plug into the breadboard. If the wire is very short, let's say you got to cut a little bit of wire like this because you're trying to be neat and tidy and only use a small amount of wire, well, you really kind of have to hold one end with the pliers. So if I hold this end with the pliers like this, and then come along, and the trick is to squeeze but not too hard. There we go. And there it comes. Now, you can actually buy proper wire strippers as opposed to just the snips like that. And these can be adjusted so that they leave a little hole, I don't know if you can see that there, in the center, which won't cut the metal, but will cut through the plastic insulation. So see, perfect every time. You just squeeze and pull. They're a little bit more expensive than a snips, and they're single purpose, but they're very useful if you're not that used to wire stripping. There are other types of strippers as well, kind of gun type ones that you pull a trigger, but I would go with a general snips, pliers. Some pliers already have wire cutter components to them, they'll do fine. But definitely you need a snips and a pliers if you're going to be neat.
Breadboard assembly.
Okay, we'll begin our first breadboard assembly exercise. I've got the LED here, and you see one leg is longer than the other. So I'm going to just put that in the board here, like so. This is my 270 ohm resistor. I'm going to place that on the board like that. I'm not going to cut any wires yet in case we need the longer leads for later. So the resistor connects into the same track here, see it's, or column 11 there, as the LED, as the long leg of the LED. And the other end is free. Now we're going to bring the other end from there up to the red power bus up here, which we're going to connect to our battery shortly. So that goes in there. And the other leg of the LED, the cathode, we're going to connect to the negative of our power bus down there. Leave room for the battery connector. There we go. Right, so the battery needs to go in next. It's a good idea to only put the batteries in the enclosure after you've put the leads in, because you might accidentally short the leads together. So there, that's in. And then let's put the batteries in. So be careful to observe polarity. There. 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 One to go. Hopefully LED should light up now when I do this. There we go. There we go. LED lights. Okay. If I try and put it in the wrong way around, watch what happens. Nothing. The LED only works if it's in the right way around. Current goes from anode to cathode.